Hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. This is number 61, so this is going to be the new set of series problems. I've been away for a little bit, but I'm back to have one a day, more or less, of these problems leading up to school starting again. So number 61, here we go. A student takes out a college loan of $10,000 at an annual percentage rate of 6%, compounded monthly. A, if the student makes payments of $100 per month, how much does the student owe after 12 months? And B, after how many months will the loan be paid off? So this doesn't really seem like a series problem, but it actually kind of is. It's like a sequence series thing going on. You have $10,000 that they're taking out. And it's at an annual percentage rate of 6% compounded monthly. If we're going to use the formula, let's start with the formula. So there's a formula for the annual percentage rate. It's A equals P 1 plus R over N T. So this formula is the compounding formula. This would be what you would use if like you were investing and you're investing a certain amount of money, and that money is going to grow over time, and it's going to be equal to more money later. So that's kind of the formula that might come to mind first, and we do kind of use part of that formula. The principal would be 10,000, and then it'd be 1 plus, and then the rate is 6%, so 0.06. The number of times compounded in a year is 12 because it's monthly. So then you have this. And then 0.06 divided by 12. I'll go ahead and spoil it for you a little bit. I worked this out earlier because this problem I was like, how is this a series problem? So I wanted to make sure I worked it out first before I showed you guys how to do it. And so sometimes I'll work it out in real time, like I've never actually seen the problem before. And then I'm like, oh, I got this. But this was not one of those. So if you got stuck on it, I can totally see how. Because it does involve kind of a complicated process, especially if you're just learning about sequences and series and you're like, what does this have to do with any of that? So if we add these up, 0.06 divided by 12 comes out to 0.005. So this is 0.005, and then 1 plus that would be 1.005. So that would essentially be, this. And can you see that? Yeah, you can. Okay. 1.005, 12t. Okay, so that would be the amount of money that it would be, granted that you don't make payments. If you don't make payments, that's what's happening. Annual percentage rate of 6%, so it's going to continue to compound at 6% monthly. So let's make another formula. But in order to do that, we need to make a table. So time in months. So we'll put T, which is in months. And then you have the amount that you still owe, right? So the amount that you still owe, and we'll just call that A for amount. And actually, let's flip that around because that's not matching the other thing. Let's get a little bit more organized. So A for the amount owed. Okay. So when we first start out, we owe 10,000, right? Pretty simple. And in the first month, there's two things that happen. So one, it gets compounded, right? So it's going to get compounded first. And that's not actually explicit in the problem. If you paid at the beginning of the month, it's actually different than if you pay at the end of the month. But I already checked out all the math, and it works out that you get because this is an odd problem. So fortunately, the answer was back there. And it only works out that you get the answer that they want you to get if we're assuming that we're paying at the end of the month instead of at the beginning of the month. So that's another thing that makes the problem not so easy, is that it's not super clear on exactly how you're paying. But if you pay at the end of the month, then the first thing that happens is you take that 10,000 and you multiply it by 1.005 because that's the 1 plus r over n number, right? And moving forward, we'll just kind of call that our new r, basically. So that's kind of the rate. It's going to get multiplied by 1.005, and that would be if t is 1/12. Kind of imagine, if t is equal to 1/12 of a year. Normally, when you're using this formula, a equals p 1 plus r over n to the nt. T is in years, so 1 month later would be 1/12 of a year. So if I did that, you can see how that would work. 0.005 to the 12 times 1 over 12 power, which would just be 1, and then that would just be 10,000 times 1.005 to the first power, which is times 1.005. So that's where I'm getting that number from. That would basically be after 1 month, how much is that going to compound? So it's going to compound by 1.005. Then you make your payment. If you had made your payment first, then it would be 10,000 minus 100, and then that number would get multiplied by 1.005, which is actually a little bit nicer, I think. It comes out to you end up paying it off faster if you pay at the beginning of the month. So, anyways, that's what that turns out to be. And I think I already did the math on this earlier, but this comes out to, it's like 9 something. Let me get my phone out. Hold on. So actually, that's going to be doop, doop, doop. 1, 2, 3. 1, 2, 3. So that would be 1,005 still times 10. So that's 1,050 minus 100. And then that's going to be minus 100. So that's going to be what, 9,950. So we can double check, but that should be what you get. And we can then find out what t is when it's 2. Let me double check because I'm not feeling great today. So my brain is a little mushy right now. 1.005. And then we're going to minus that 100. Okay, yeah, 9950. Okay. So then what's the pattern? Well, we would take that new number, that 9950, but I'm going to write it as what it was before I simplified it. 1.005 minus 100. So that before it was simplified, it was that, right? So that's the new amount. And then next month, what happens is you have that compounding because of that 6% rate compounded monthly. And then you're going to make a payment by the end of the month. Okay, so then what does that come out to be? Well, that comes out to be 10,000 times 1.005 minus 100 times 1.005 minus 100. And let's see, so that's 9950 times 1.005 minus 100, and that comes out to 9899.75. 9899.75. So basically, what happens is uh, that 6% is not like a 6% that's multiplied by the 10,000, and then that number is the number that you're paying down on. No, no, no. It comes out to like 6% is going to keep going. That 6% is going to keep adding. So that makes it a little worse. So it comes out to that in the second month, but we need a formula, right? We need a formula because we're going out to 12. You could just keep doing it over and over and over again until you get to 12, but we need a formula that works. So let's look at the pattern. Well, actually, you know what? Let's go back. Let's get rid of that because I want to go down before I get to 3. So the pattern here is that if I distribute this 1.005, it would go here and here, right? So that's going to be 10,000 1.005, and then that's times by another 1.005. So now it's squared. Minus 100 1.005 minus 100 from right there, right? Okay, well, what is that? Well, here we've got an extra 100, and here we've got 100. We can consolidate those. So it's 10, 0, 0, 0, 1.005 squared minus, and then that's 100, and then that's 1.005 minus 1. Okay, so what's going to happen is I'm going to take all of that and multiply by 1.005 again, and then minus 100. So what is going to end up happening is if I multiply all of this by 1.005, the easiest and the simplest thing that happens is that I have my 10,000, and that's going to go up by another power, right? Now, all of this other stuff gets multiplied by 1.005 as well, right? So then that's going to be 100, 1.005 squared minus 100, 1.005 to the first power, because I'm multiplying that by 1.005. So that's everything everything got multiplied by 1.005. And then I'm going to subtract another 100 on top of that. So that's going to be when we get to 3. And I'm not going to calculate that because it's not useful. We need to know what happens after, what was it, 12 months, right? After a year. Let's go back here. Yeah, if the student makes payments $100 per month, how much does the student owe after 12 months? So after 1 year, right? So after 12 months, after 1 year. And so what's the formula? What about if I want some sort of X amount of months, right? Okay, well, the first part's actually not too bad. This would just be 1.005 to the X. And then you'll notice all of this stuff, it keeps going down. One thing I can do is I can take out that 100 because all of them have it. And then it's 1.005 squared. Um, and then minus. So actually, let's hold off on the X for right now. So this is 3. Let's hold off on it just a moment longer because the first part's actually not too bad, right? We can just take it and just call it X. That's going to be whatever month it is. The other part is a little bit harder. So let's look here. 1.005 to the first power minus 1.005 to the 0th power is another way to look at it. That's essentially what's happening. When I was working this out, what I actually did was I ended up making a sum, which is why I was thinking like, wait, how are you supposed to do this with a sequence? You can't really do it with just a sequence, but I guess we're getting to the end of this set before we get into actual sums. So they're kind of having you dip into sums. I really wish they hadn't had you dip into sums in this way because I feel like this is an overly complicated way to try to be like, hey, sums exist, but we're not going to teach you them yet because we're technically still on sequences. But what's happening here is it's going down each time. So if we use the formula, there's a formula, and I didn't grab it. It was Sn is a sub 1, and then it's going to be r Rn over R1. I think it was like that. So, and we'll double check it to make sure we get the right answer. But there's a summation formula here. So we're adding a bunch of different things, right? We're adding we're adding a ton of things. So, and the R is going to be the rate of what we're adding because it's a geometric sum. So this is going to be the 1.005 is the R in this case. And we're going to take out that negative 100 and just view it as, oh, sorry, that would be plus. These would all be pluses. So we're going to take out this negative 100 and just view it as basically, so recursively, this would be 1 plus 1.005 plus 1.005 squared plus dot, 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 dot. And you would have to keep going until you get to the x minus 1 term. 1.005 to the x minus 1. Right? Because in this particular one, we're stopping at 2, not at 3, even though we're looking at the third month. So Uh, the R ends up being the 1.005 in this case. And the N is just the X. The N is just the X. And then the first term of just what's in the parentheses, not the minus 100, the first term would actually just be 1. So that makes it a little easier. So then this ends up turning into 1.005, and we've got that negative 100 outside, right? So 1.005 to the x power minus 1 over 1.005 minus 1. And then we've got this to the third power. And then that, now we can take that 3 out and just call it x. And so this would be the amount after x years. I could have used in, that probably would have been better, but it is what it is. So now I have a formula. Now this is a formula that tells me the amount that I should have. And whenever you create a formula like this using other, formulas and stuff, you want to make sure that it works. So you want to type it in and make sure it works. But to make the video a little bit shorter, you can pause it and you can type in 1 for x, and you can make sure that it works for x equals 1 and for x equals 2, since we already evaluated those at x equals 1 and x equals 2. So I'm going to get out my calculator, my phone calculator here, and I'm going to go ahead and do 12 because I wrote down the answers that I got. So I'm making sure that I'm going to get the correct answers here. So if we're looking for 12, the 12th month, after 1 year, it'd be 10,000, and then it would be 1.005, and then that's going to be to the power of 12, and then that's minus 100, and then parentheses 1.005. I'm just using my phone calculator here, but you can use a scientific or a graphing calculator, and that would also work just fine. If anything, even better, because phone calculators are a little weird sometimes. So that's minus 100, 1.005 to the 12th power minus 1. All of that is over 1.005 minus 1, which would be just 0.005. All right. And I get, here's what I get. So when x is 12, the amount I get, A12, I'm going to round to the nearest cent because that's, we're talking about money. So the nearest cent. Um, Now, the book answer actually left off the cents. I'm not sure why, but because they didn't say to round to the nearest whole number, but it's actually 9,383 and 22 cents. So that is what we get for when we plug in 12 into x into this formula. So that is the first part, and that's A, right? So B, after how many months will the loan be paid off? Okay, so we know A12 is a certain amount, but we're looking for the AX such that it's paid off, which means it would be 0. We're looking for when the amount is 0. So we want to know what's the X value in which I get 0. So we want to know, we know AX is 0, and we want to know what X is, right? So we would just say, okay, well, then it's equal to 0, right? And I'm going to put my phone down because this is the solving part, so I'm not going to do my phone just yet. So 1.005 to the x minus 100, 1.005 x minus 1, and then all that's over 0.005. So the first thing I think I'll do um, is I think I'll distribute the 100. I did this a little differently when I first did it. I think I did it in more steps than I needed to do it, and that's why I'm kind of thinking like, let's see if I can do this in less steps. So then this would end up being 10,000, 1.005 to the x power, and then that's minus, and then this is all over 0.005, so that's 100 over 0.005 times 1.005 to the x minus 1 times that 100 over the 0.005 still. Okay, so then I don't need this part, this other part over here. So I'm going to add that to both sides. And it might be helpful to figure out what this is. It looks like it'll turn out to be a fairly nice number. So let's figure out what that is. 100 divided by 0.005. And that's 20,000. Ah, yes, of course. So if we add 20,000 to both sides, so we're going to add 20,000 to both sides. Because remember, we're trying to solve, right? So we have everything with x in it all on one side already. We just need to get everything that doesn't have x in it on the other side. And that's what I'm doing now. And I'll actually accomplish that in one step. Then I've got this. So I've got 10,000, 1.005 x. And remember that 100 divided by 0.005 is 20,000. So that's minus 20,000, 1.005 to the x power. And then looks like I can just put these two together because I get 1.005 to the x. So then that would be 10,000 minus 20,000, which is negative 10,000. 1.005 to the x equal to 20,000. And you know what? I'm missing something. Hold on. I'm feeling like I'm making a boo-boo here, and I found my boo-boo. So when I distributed, I forgot to say that that was negative 100 times negative 1, which would be positive. So I'd want to subtract that on both sides. There we go. Thought something felt off. So then we would want to subtract it on both sides, not add it on both sides. So then let's see. So then that would actually be, yeah, that's still going to be negative. Okay. So then I want to continue to try to get my x by itself. And by the way, if you've seen some of my simpler videos, not calculus stuff, but earlier stuff, I tend to talk about this more. But anytime you're solving any equation, as long as they're not more than one kind of x, you're basically just doing PEMDAS backwards. And so that's kind of what I'm trying to do is I'm just doing PEMDAS backwards. It looks like I'm getting, hold on. Did I write too many zeros? I think I wrote too many zeros. Yeah, it should have been 20,000. Yeah, that was 20,000. Okay, so then that should be 2. Like I said, I'm not feeling well today. 1.005, making excuses. No excuses. So then I would just change it into a logarithm. When you're changing it into a logarithm, the base stays the base and the other switch place. So it would be a log base of 1.005. And then the other two numbers would switch place. So then instead of the x being connected to the 1.005, the 2 is going to be connected. And then instead of it being equal to 2, it's going to be equal to x. And there we go. I've solved it. And then I just need to plug it in. If you have a calculator that does not do log bases other than 10 and e, that's fine. You can just use a log or an ln. I usually use log, but I'm going to use ln. I'm going to switch it up. So as I'm typing it into the calculator, I'm going to need to do ln of 2, close the parentheses on the 2, and then divide, and then ln of 1.005. And I get 138.975, blah, 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 blah. It takes it out to a lot of decimal places. Well, remember, we're thinking about how many months it's going to take to pay it off. So you're going to pay it off. The last amount you'd have to pay wouldn't be $100. Like you're not going to pay them more than $100. And then pay them more than you need to pay them, right? So your very last payment wouldn't be exactly $100, but because it's 138 point something, it means it wouldn't be, even if it was low. So even with standard rounding, I would say 139 months. But even if it wasn't, even if it was 138.2, that still means you'd have an extra payment. That payment would be pretty low. That last payment would be maybe like $20 instead of 100. This is 138.9 something. So you're basically paying $100 that last month, that maybe it's like 95 or something. It's somewhere in the 90s. So you're paying almost a full payment that last month, but it's not quite a full payment because you don't need to pay them more than what you need to. You just pay them the exact amount. So it comes out to 138 point anything other than 0.000000000, then it would be rounded up to the next month. And so that's going to be 139 months. Phew. Okay. So that was the question of the day. That was quite the question of the day to start off with, but there we go. So hopefully that's been helpful. You can check out more videos on my channel, Myers Mathematics, and you can go over to my website and check it out as well. I normally would say check out the 5 math mistakes everyone makes and how to avoid them, but I need to make an update to that. So I think I'm going to change it. I think I'm going to change it into something else, something much, much better. So what I would say though is just go check out what I have to offer. It's myersmathematics.com, and then you click on it's like store or offers or something. I don't know. And I've got a ton of different things you can look at on there. I'm going to start doing free tutoring on Tuesdays online. If you are looking for in person, obviously, if I'm not in your area, it's not going to work out. But I live in the Sun City Center area. There's a library nearby that I'll be doing free tutoring at in person starting in the next week or so. And I think so that'll be the 2 different kinds of free tutoring that I'm doing. And then if you look, there's also a subscription where it's kind of like Chegg, but it's going to be cheaper. So it's cheaper than Chegg, and it it's essentially going to work similar to Chegg. Although instead of just doing solutions, I'm going to probably do videos. I don't know for sure yet. I'm at least going to do solutions, but I'll probably also do videos as well. And that way you get a more fuller picture of how to answer a question. So if you're looking for a specific answer to a question, you can subscribe to that. It'll be just like a monthly thing. And then tutoring itself. So if you're looking at getting in-person tutoring, then you can check out my options for that as well. So all of that's on my website, myersmathematics.com, and I'll have that link down in the description below. Go check it out, and I'll catch you in the next video. Blessings, y'all.